Hi. Okay, so we're going to talk a little bit about fractional exponents right now. Now, this is a pretty hard concept, so that's why I want to make a video. Maybe it will help you out with your homework. Okay, before we get into fractional exponents, one thing we have to understand is the concept of roots. Now, up to now, you've seen things like this. That's not what I want. You've seen things like this. The square root of 16. And you know this is asking the question, what number times itself equals 16? What number do I need to fill in here? Well, you know that it's 4, okay? And that answers this question, okay? 4 is the square root of 16. Okay, now there are other roots other than just the square root. There are infinite number of roots, actually. So we have something called the third root. So if I take the third root of 8, this is asking the question, what number multiplied times itself 3 times equals this number here underneath this radicand sign? What number do I need to multiply times itself 1, 2, 3 times to equal 8? Well, that's 2. So we would say that the third root of 8 is equal to 2. Now, I hope you can see the relationship here. This number is asking how, well, this number here is indicating the number of times that this number needs to be multiplied times itself to equal this number. Okay, that's the concept of a root, a higher root. Okay. So there's another way of writing that. For example, I can write the square root of 16. There's kind of like a 2 here. We don't write it, but there's always a 2 here. And I can write this as 16 to the 1/2 power. Okay, do you see that? The 2 here and the 2 here. And the 8, the third root of 8, I can write as 8 to the 1/3 power. That's the definition of the denominator in fractional exponents. Okay, we call this a fractional exponent because obviously it's an exponent and it's a fraction. The denominator in this exponent is saying, take this number here, our base, and take this root, the third root in this case. If I had another one like 81 to the 1/4 power, this is saying take the fourth root of 81. And again, just to remind you, that's asking the question, what number times itself 4 times equals 81? Okay, and that number's 3. So the fourth root of 81 is 3. It's the number that you need to multiply times itself 4 times to equal 81. And another way of writing that is just saying 81 to the 1/4 power. It's quicker and a little bit cleaner. Okay, so let's do some examples. No, we're not ready to do examples yet. Okay, the next thing you need to realize is that the numerator is just the same as regular exponents. Let me give you an example. Okay, let's just do an example here. So let's say that I have 25 to the 3/2 power. And I'm just going to use this example to show you what the fractional exponents mean. First of all, we're going to take the second root of 25 because the 2's in the denominator. Okay, so I'm thinking in my head, square root of 25. Then what this numerator says is we're going to take that, and I'll even put it in parentheses here, and we're going to raise whatever this is to the third power. Okay? These are equal. So let's see, the square root of 25 is 5, and I'm raising that to the third power, which is 125. Okay, it's not too complicated as long as you break it down into simple steps. First of all, take this root. Could be a 2, could be a 3, could be any number. You're going to take that root, and then you're going to raise to this power. Okay, let's do another example. 16 to the 5/4 power. Okay, so in my head, I'm thinking the first thing I want to do is take the fourth root of 16. So I'm thinking what number multiplied times itself 4 times equals 16? Whatever that number is, we're going to raise that to the 5th power. Okay, this number happens to be 2. So this entire thing in parentheses simplifies to 2, and I raise 2 to the 5th power, which is equal to 32. Okay. Let's do another one. 81 to the 3/2 power. Now, I'm going to let you know you could take 81 to the 3rd power and then take the square root, but that's way, way more difficult and way more complicated. And, you probably couldn't do that without a calculator. This way is easy. Always take this root first. Okay, so we're going to take the square root of 81, and then we're going to raise that to the 3rd power. Remember, taking the denominator's root, raising to the numerator's power. The square root of 81 is 9. We're going to take 9 to the 3rd power, which I believe is 729. And that's your answer. These right here will be your final answers. Okay. Let's do a couple more. Now, when you have a negative exponent, okay, now we learned what negative exponents were a couple days ago. And let's do an example. 9 to the negative 3/2 power. Now, I hope that, and this is a negative sign there. It's not really very clear, but it is. All right, so I hope that you remember that this is just going to be the reciprocal, so 1 over this to the positive 3/2. So 9 to the positive 3/2 power. Okay, so just remember that we're going to find this like we normally do, and it's going to stay in the denominator. So this is going to be 1 over, take the denominator's root, so that's going to be the square root of 9, and then we're going to raise that to the numerator's power, which is 3. Okay, so this is 1 over the square root of 9 is 3 to the 3rd power, which is 1 over, I'll do it over here, 1 over 27. And that's your final answer. Okay, now it's important to remember that with fractional exponents, all your other exponent rules still apply. So, do a quick example here. If I have x to the 1/2 times x to the 2/3, well, I'm multiplying powers with the same base. I add exponents. So this is going to be x to the 1/2 plus 2/3 power. I'll even put that in parentheses. Okay, 1/2 plus 2/3 is what, 7/6? So x to the 7/6 power. And what this would mean was I would take whatever x is, I would take the 6th root and raise that to the 7th power. Okay, do not use mixed numbers here. Just keep it a fraction. We like fractions. Okay, let's do, I'm going to help you out with a problem that's very similar to your number 6 on page 14. That's a pretty complicated problem. So let's take a look here. All right. A closed box is, and I use different exponents, so I'm not giving you the problem. Don't put this answer down. Okay, so a closed box is x to the 2/3 wide, x to the 3/5 long, and x to the 1/2 high. Okay, so all those fractions are exponents. Okay, great. It doesn't mean anything. I mean, I don't know what x is. If I knew what x was, then I could find out how big this box is. But right now, they're just giving us information. Okay, find the box's volume in terms of x. Well, we know, can I write on this? Oh no. I'll have to make this in 2 videos because I'm running out of recording time.